Hello everybody, getting ready to do lesson 3.4 part 1, pre-calculus math today, the classwork. If you need note-taking guides, email me here, solution PowerPoints or other videos and PowerPoints, contact me here for those. 3.4 part 1, solving exponential and logarithmic function, or rather equations. Logarithmic equations. We got 62 points here of classwork, so note-taking guide would really come in handy here. And we only have 2 points here for your notebook, so take note of that. And teachers, here is your bell work for the day. Sketching graphs. Students, sketch these graphs here, and we're going to see how you do on those. And teacher, give your students about 5-6 minutes for that. Okay, welcome back, students. Hopefully these are finished for you. And this is how this graph should look like here. This one here is a perfect inequality, negative x squared plus 4. So you start here and has a negative slope. And then up here just 2x, which is a linear equation there, and for x less than 0, so you have an open dot there for x less than 0. And then down here, x minus 9, x is less than or equal to negative 1, so that would be down here. So we have less than or equal to negative 1, x minus 9, so you're down here. So the graph actually has a positive slope here of 1. And it has a y-intercept here, negative 9, which would be about here. And it's less than or equal to, so it has a solid dot there. And then x squared plus 1, x greater than negative 1. So it starts over here with an open dot. And then it's a parabola, and it has a y-intercept here of 1. And then it goes up the other side like that. So there are your plots. Students, take note of that. Into our lesson today. Here's your notebook, first page here. So far you've studied definition, graphs, properties of exponential and logarithmic functions. In this section you will study procedures for solving equations involving exponential and logarithmic functions. There are two basic strategies for solving exponential or logarithmic equations. The first one is based on the one-to-one property, and the second is based on the inverse property. For a greater than 0 and not equal to 1, the following properties are true for all x and y, for which log base ax and log base ay are defined. And then the one-to-one properties, a to the x equals a to the y, if and only if x equals y. So when you knock out the base here, you'll have x will equal y, and that's called a one-to-one property. And then same thing here, log base ax equals log base ay, if and only if x equals y. Same thing there. A one-to-one is what they call that. And then inverse properties here, a to the log base a to the x equals x. Because this will cancel out each other, and then your x will drop down, and it'll be x equals x. And then log base a to the x will equal x2. These will cancel out each other, and then your x will drop down, and then that will equal x here as well. And these are inverse properties here. Okay, into our classwork today. Okay, solving simple exponential logarithmic equations. Original equation, rewritten equation, solution, and then the property of how you solved it. Okay, so first of all, up here we have 2x. 2 to the x equals 32. That's our original equation there. And then the rewritten equation will be, what is 32 with base 2 will be 2 to the 5th. And then the solution would be x equals 5 for here. X would equal 5 here because 2 to the x will equal 2 to the 5th. And then we just throw away our bases and we'll get x equals 5. And then the property was, they call it 1-to-1, but it's like the equality of exponents really is what you're doing here. And then log base 4x minus log base 4h equals 0. And then we're going to rewrite this to log base 4x equals log base 4 to the 8 of 8. So then we're going to move this over here. And then we're going to get, well, x equals 8 because we're going to get rid of this log base 4 on both sides. That's another 1-to-1 kind of situation. And then natural log x minus natural log 3 equals 0. We're going to move our natural log 3 over to the other side. We have natural log x now, and that equals natural log 3. X equals 3. That is another 1-to-1 as well. And then 1/3 to the x power equals 9. So basically this is 3 to the negative x is what this is. Equals 3 squared. We have the same base here. So we throw away our bases and we solve for x, and then negative x will equal 2, or x equals -2. And that's another situation of 1-to-1 there. And then e to the x equals 7. So we're going to use a natural log e to the x equals natural log 7. This is natural log e to the x, so that's going to cancel out. The x will drop down. Now we have x equals natural log 7, and that is solved by using an inverse property there. And then for natural log x equals -3, we're going to jump up our natural log x here to e. E to the natural log x power equals e to the -3. We have the same base here is what we have. But natural log e to the x, it'll cancel out, and then the x will drop down. Now x will equal e to the -3 power, and then that's using an inverse property here of logs to get this situation, whatever that is there. We'll use inverse technique there. And then log base 10x equals -1. Then we're going to jump it up to 10 to the log base 10x equals 10 to the -1 power. And then so this will move over to here. These will cancel, 10 log base 10 to the x. These will cancel out. The x will drop down. X will equal 10 to the -1, which is the same thing as 1/10. And that's an inverse technique there of solving this. And then log base 3x equals 4. We're going to have 3 log base 3x equals 3 to the 4th. So we're going to jump up everything using the base 3 on both sides. This will cancel, so this will drop down, and we'll have x equals 81, and that's using an inverse technique as well. So there's examples of using 1-to-1 and inverses. Let's try one now. Solve the exponential equation. This is our exponential here. Students, this is yours down here. Okay, so for our first guided practice here, 1/8 to the x equals 64. So we can use something here to put everything into base, using a base of 8. This is 8 to the -x equals 8 squared. And then we have the same base, so we can throw away our base, and we have -x. This will drop down, and then this will drop down. X equals -2. Then x would equal -2. So take note of that down here, students, for your independent practice. Okay, classwork, page 4, strategies for solving exponential and logarithmic equations. Rewrite the original equation in a form that allows the use of the 1-to-1 properties of exponential or logarithmic functions. Rewrite an exponential equation in logarithmic form and apply the inverse property of logarithmic functions. Rewrite a logarithmic equation in exponential form. So see how we're going from log to exponential, from exponential to log, and apply the inverse property of an exponential function. Okay, let's get into another example here. Example 2, solving exponential equations, page 5 of your classwork. Solve each equation. So e to the x equals 72. So we can use natural log here because e is the base of a natural log anyways. So natural log base e to the x equals natural log 72. What we do on this side, we have to do on this side. And you know these are going to cancel out. Take natural log of each side, so this will cancel here, and the x will drop down. X will equal natural log 72. That's an inverse technique there. And then the natural log of 72 would be 4.28 after using a calculator. And then here's the graph here. We have a y equals 72. We put the right side as a horizontal line here. And then e to the x will be this curve, and then where they intersect here will be 4.28. That'd be another way of checking your inverse technique. Okay, and then b, 3 times 2 to the x equals 42. So we can divide both sides by 3 here, and we isolate our 2 to the x power equals 14. And then now we're going to use the log base 2 on both sides because we want to get rid of this exponential here, the base here. So if we take log base 2 to both sides, these will cancel, and then your x will drop down. So take log base 2 of each side. And then we're left with this. X will equal log base 2 14. This is the inverse property. And then by using change of base here, so we're going to take natural log 14 over natural log 2, which is what we've done. Here's change of base formula. And then when we do that using a calculator, we get 3.81, and the solution is log base 214 is 3.81. Check this in the original equation. You could do that with a calculator, or you could graph it. So our original horizontal would be y2 equals 42. That'd be up here. Make sure your window's big enough so you can contain that. And then 3 times 2 to the x, that'd be this curve here, and then where that intersects will be 3.81. That'd be another way you could check yourself on that. Okay, I think the graph here pretty much says it all. Let's go on to our next guided practice here. We have 6 times 10 to the x equals 216. Down here, students, you have this here. I'll let you do that. Let's do this one first up here. Okay, so this here we're going to divide through by 6. So we have 10 to the x equals 36. So we use a log base 10, a common log on both sides. Your 10s will go away, your x will drop down. Then x will equal log base 10, 36, which is 1.5563. You plug that back in there, check it, or you could graph it. Let's go on to our next example. Example 3, solving an exponential equation. 4e to the 2x minus 3 equals 2. So what are we going to do here? We're going to move this 3 over here, so we get 4e to the 2x equals 5. Now we're going to divide through by 4 on both sides. We have e to the 2x equals 5 over 4. Then we're going to get rid of this e by taking a natural log base e of both sides. Natural log base e, 5 over 4. So our e will go away, and then our 2x will drop down. We have 2x equals natural log 5 over 4. And then we isolate our x here now from that. we get 1/2 natural log 5 over 4, divide each side by 2. And then that will be x equals, when you do this on your calculator, you'll get 0.11. And then here is a graph of it here. Y equals 4e to the 2x minus 5. So we have a 0 here at 0.11. This is where your solution is to this equation here. That'd be a way of checking it by using a graph here. Let's try one now up here. Round your result to 3 decimal places, solve the exponential. We got this up here, then down here, students, this is yours. Use a graphing calculator to check it. So, to solve this thing here, we're going to go through and divide both sides by 500. And we get e to the negative x equals 3 over 5. And we're going to get rid of this e, so I'm going to take the natural log both sides. So then we end up with negative x equals natural log 3 over 5. Get rid of this negative 1, so now we have negative natural log 3 over 5, which will equal natural log 5 over 3 here. This negative 1 is the same thing as 3 over 5 to the negative 1 power, so we reciprocate that. We take natural log of 5 over 3, and we get that there. And you can check that by plugging that back into the original to graph it. Let's go to example 4, solving an exponential equation. Solve 2 times 3 to the 2t minus 5 minus 4 equals 11. So I'm going to move this 4 over here. We get this situation here. And then we're going to divide through by 2. We get rid of the 2 over here. Divide each side by 2. Now I'm going to use log base 3 to 2t minus 5 equals log base 3, 15 over 2. The 3 will go away, the 2t minus 5 will drop down. So we have 2t minus 5 equals log base 3, 15 over 2. Inverse property there. And now we're going to move over our 5. So we have 2t equals 5 plus log base 3, 7.5. We're going to add 5 to both sides. And then we're going to divide through by 2 now. We got our t isolated. So we have 5 over 2 plus 1/2 log base 3, 7.5. And then when we do this on a calculator here, we'll have 3.42. And we can use a calculator, or rather we can use a graphing calculator to solve that as well, or we can just plug it back into the original, which is what we did there. So now, round your result to 3 decimal places, we have another situation here, real similar to that prior problem. Students, this is yours. Let's do this one up here. So we have this situation here. 5 times 2 to the 3 minus x minus 13. And we add 13 to both sides. We divide through by 5. We take the natural log of both sides. And we take the natural log of both sides is what we do here. Then we end up with 3 minus x equals natural log 113 over 5 over natural log 2. We get rid of our 2 here. Natural log 2 equals natural log 113 over 5. Or rather, yeah, and over natural log 2. Then we move our 3 over. X equals 3 minus natural log 113 over 5 over natural log 2. And then when we crunch this with our calculator, we get this number here for that. So after a lot of number crunching on your calculator, you should get that, and then you can plug that back into your original, and you should get 100 here after you do your number crunching over there. Okay, example 5, solving exponential equation in quadratic form now. So we got a little bit of a resemblance here of a quadratic. So this is in quadratic form. We're going to factor this here into e to the x minus 2, e to the x minus 1. So we got two binomials there. And then e to the x minus 2 equals 0. That'd be 1, 0 there. There's our first factor equal to 0. And then e to the x equal 2. And then we'll get x equals natural log 2. We take natural logs of both sides here. And we get this number here. That's one solution. Then for our second solution, e to the x minus 1. Then we solve for x here. E to x equals 1. Move this over here. Then take the natural log of both sides. Then we get x equals natural log 1, inverse property. And the solutions are x equals natural log 2 and x equals 0. And then here is the graph of that quadratic. Here's the solution here. As 0 occurs at x equals 0, the origin, there's 1, 0. And then there's our second 0 there. Confirms this here, 0.69. 0.69 y equals 0. Okay, let's do our guided practice here. Okay, so finishing doing our guided practice here, we have e to the 2x minus 4e to the x minus 5. It looks like it's somewhat in quadratic form. Round your result to 3 decimal. We're using our graphing utility to verify. So when we have this here, this is our original, and then we can just factor this into these two binomials here, e to the x minus 5, e to the x plus 1. That is our two binomial factoring of this quadratic. And then we just solve for each one of these here. E to the x will equal 5, or e to the x will equal negative 1. Then x will equal natural log 5 equals this number here. And then e to the x will equal negative 1, which is impossible. You can't get a log to equal a negative. So there's your solutions there. And that is your lesson for pre-calculus math. If you want a solution PowerPoint for your homework, email me here. No taking, guys. You really didn't need one for this one. And but if you want one for a past lesson, email me here. Thank you very much.